Hello, am I audible? Yes, everyone. So I think may audible perfectly. So till now we cover that RC. Okay, that what is RC? You know that you have a delay. Okay, of course you have a RC means you have a delay, and not the meaning is you have a physically RC. It may be present by the help of metal. Okay, you have a metal rod, so it have a resistance. If the two metals are in parallel, so of course it will form a capacitor. So these are the parasitics also, so they will affect your result. So how it can be affect your in circuit? So we generally say that okay, you have a input and the input have a sudden change, and that the capacitor is charging will take time, and that will take exponentially charging is happening. Okay, and that is expression is v final plus v initial minus v final e to the power minus t by tau, and that is very basic equation. This is come from that basic first order equation, that is dy by dx plus py is equal to q. Okay, and then we talk about, okay, you have a diode, what will be the effect? Okay, so if you have a diode with a parallel of resistance, so basically diode is a unidirectional device. It will follow that one path. Okay, if you have a anode and you have a cathode, and anode potential is greater than the cathode potential, it will behave like a short circuit. Or if you have a cut-in voltage, so it will be a v gamma. Okay, and it will charge capacitor suddenly. Okay, so let's talk about today we have one more question. Last time we discussed one question with a diode, and I gave that assignment in a last class. If you done it, that is okay. If you don't, so please solve with me. Okay, we have a input voltage, we have a diode D1 and D2, and D2 is connected with a 5-volt supply, and you have a resistor and capacitor. Now I am talking about what will happen if you have a T1 to T2, that in between T1 to T2 you have a that on that is logically high, that is 10 volt, and after T2 it have a 0 volt, and before T1 it is 0 volt. And let make that T2 minus T1 is far greater than tau. That means time constant is very small as compared to pulse width. So that's why what will happen. So let's talk about before T1 what is happening. So before T1 means the input voltage is 0. So I am just making, okay, whenever you have a question of RC, or whenever you have a question, just break that question. In terms of that will be easy for you. If you solve in a single flow, that will be difficult for you. So let's start with a basic that key. Okay, this is first region, this is second, this is third, and this will be fourth. Whenever that before T1 what will be the state, after T1 what will happen, then T2 minus, then T2 plus. Okay, and what will happen after some time. Okay, so we will follow that this path. So let's start with the before T1. So before T1 that input voltage is 0. Before T1 the input voltage is 0, so means the input voltage is 0 means the internal resistance is 0, that is short circuit. And you have a diode here, that is D1, and you have a resistance, and then you have a capacitor here, and you just convert into D2 in a way, just it will be easy. So you can make like this, that logic in this way. Okay, so you just convert this, the D2 anode, that the negative N side is connected to V out, and positive P side is connected to 5 volt, and you are talking about what is V out. Let this is D1 and this is D2, and this is 5 volt, and this is resistance, and the input voltage is 0 there. The input voltage is 0 before T1. So I just make that logic in a way, the input voltage is 0, and D1 you have, and you have a resistance, and you have a D2, and you have a capacitor. So whenever I am talking about before T1, that means input voltage is 0, and it is 0 for a long period of time, that is called a steady state or DC state before T1. So in a DC state the capacitor act like an open circuit, so just I make that capacitor act like an open circuit. So what is happening, so capacitor will take any voltage across it because it will be open, and that will be limited by the resistor or that voltage, that circuit. So just I am thinking in a way, okay, if there is any current, yes, there is no any current here because there is no any external supply. So I can think in a way what will be the voltage here. If this is 5 volt, there is no any external voltage here, so this D2 will be a forward bias. Similarly, if this is a forward bias, so it will be short circuit and become a 5 volt here, and this is also a 5 volt because this is short, and this have a 0 volt. So this D1 is reverse bias and D2 is forward bias. Before T1, so I am looking in the circuit that D1 is reverse bias and D2 is forward bias. Yes, please check it. What I am saying that okay, before T1 the input voltage is 0. So the input voltage is 0. So this is a short circuit. You have a D1, you have a resistor, you have a capacitor, and you have a diode. Okay, if you're looking this 5 volts, so there is no any external voltage, so this D2 will be a forward bias, and if this is forward bias and diode is ideal, so this will be a 5 volt, the V out is 5 volt, and this is 5 volt, so this all I have a same node, this is also a 5 volt, this is also a 5 volt because parallelly the voltage is same. So this is 5 volt, this is 5 volt, this is 5 volt. If this is 5 volt and that this is ground, so this is 0 and this is 5 volt. So that D1 is a reverse bias and D2 is a forward bias. Just like this, and we can say that what is V out? Before T1 V out is 5 volt, and what is the capacitor voltage? The capacitor voltage will be same as your V out. This is the direction is like this. The direction is very important. Okay. So I am just saying that 5 volt with respect of ground. So this is positive and this is negative. So the capacitor voltage is also 5 volt here. Okay. So this is the very basic thing before T1. Before T1 the capacitor voltage is 5 volt and V out is 5 volt. D1 is a reverse bias and D2 is a forward bias. Okay. Okay, that once you go for the interview, they will ask in a way, okay, before T1, what will be the happen on the D1 and D2? So just figure out, okay, the D1 have a P side is a 0 volt and the right side on the N side you have a 5 volt. So of course that V1 minus V2 या VA minus VB greater than V gamma is fail here for D1. So that's why D1 is a reverse bias, and D2 you can look it in a way that the D2 have a supply and it will be a forward bias. Yes, is it okay? So this is the way you can. Okay, let's talk about at T1 plus. So at T1 plus, what is happening? The input voltage become a 10 volt. The input voltage become a 10 volt and you have a diode D1 and you have a resistance here. The capacitor is present here with the supply of 5 volt and this is D2 here with the 5 volt DC supply. So this is the circuit at T1 plus. Okay, so if you are looking this circuit, so as we know that capacitor does not allow sudden change. Of course, capacitor will not allow a sudden change. It will maintain that will VC T1 plus is equal to VC T1 minus. As we know that till now we discussed that capacitor does not allow sudden change. But what is happening in this? When you have a 10 volt, this have a 10 volt and this have a 5 volt here. Of course, this will be a forward bias. The D1 will be a forward bias there. And if this is forward bias, so this will be a short circuit path and the current is flowing here. And if the current is flowing in this path, a large amount of current is flowing. I am not saying that capacitor suddenly change. I am saying that capacitor will change rapidly. For a sudden change, you have an infinite current that physically it is not possible. It is impossible. But the current is very, very large. As per that, you have an input is 10 volt. When the input is 10 volt, that the current is not flowing in this path, that the follow the current in this path only. and here that resistance is not present, and I can say that the large amount of current is flowing through the capacitor, and capacitor will rapidly change the voltage. That will be not 5 volt, it will become a 10 volt here. As per this, D1 is forward bias, so the capacitor is not remain 5 volt. It will try to make it 5 volt, but what is happening, as per D1 have a P side have a 10 volt, and for N side you have a 5 volt. VA minus VB, 10 minus 5 is greater than V gamma, and V gamma is 0. Let this, the diode have a cut-in voltage is 0. So 10 minus 5 is greater than 0. The condition is true that this, the D1 is forward bias. If D1 is forward bias, the short circuit path is happening, and the current is maximum current flowing through this capacitor only, because there is a less resistance path. There means there is no resistance present. And I am not saying the current is infinite, I am saying that the current is very large amount through the capacitor, and by this the capacitor will change rapidly. I am not saying that instantaneously. Don't say that instantly with that the capacitor will change the voltage. The capacitor always growing, that gradually it is changing voltage across it. So I can say that capacitor will rapidly change from 5 volt to 10 volt. Okay, and the current is very large through a capacitor, and what will happen, so this, as per this, it will not maintain 10 volt, it will be go for is 5 volt, it will become a 10 volt here. Okay, and if this is a 10 volt, if this is a 10 volt, this have a 10 volt and this have a 5 volt, the D2 will be reverse bias. So in a second case at T1 plus, D1 is forward bias and the D2 is reverse biased here. Yes, please check it. Okay, I am just following that. Okay, just T1 plus, the input voltage is 10 volt and diode is present in array, and initially that capacitor have a 5 volt. So capacitor will not allow a sudden change, it will maintain 5 volt. But the condition is when the input is 10 volt and D1 will try to make it forward bias, so this will be short to that, and the capacitor have a large amount of current is flowing through it because the resistance is not present. I am not saying that infinite, but I am saying that a large amount of current is flowing here through the capacitor, and the capacitor will gradually changing the voltage across it from 5 volt to 10 volt. And if this is 5 volt, the voltage across R also is 10 volt. Sorry, the voltage across capacitor is 10 volt, so it will be also for resistance also. Why? Because parallelly the voltage is same. Okay, so in this at T1 plus, the capacitor, the V out become a 10 volt. It will not suddenly, the capacitor change the voltage gradually from 5 volt to 10 volt, and here that tau is nearly about 0 because there is no any resistance here. Okay, if you talk about the practically, that will be a tau is nearly about 0, so that capacitor will gradually changing from 5 volt to 10 volt, and it will be a 10 here. Okay, and this is the condition till T2 minus, till T1 plus to T2 minus. This is the circuit. If you are looking that input voltage, the input voltage after T1 plus to T2, the input voltage is 10 volt always. If the input voltage is 10 volt always, so this circuit is remain same, that always it have a 10 volt and this will be remain that voltage. Okay, there is no changes of the circuit till T1 plus to T2 minus. The circuit is remain same, and V out will be a 10 volt, or I can say that the VC is also 10 volt, the capacitor voltage, and the direction is same because the current is flowing from left to right, higher potential to lower potential, and D2 is remain reverse bias and D1 is forward bias till T1 plus to T2 minus. Let's talk about at T2 plus. So before T1 minus, after T1 plus to T2 minus, and then the sudden change is happening at T2 plus, the input voltage become a 0. So when the input voltage become a 0, and that is very important point, just be focused here, the input voltage become a 0, what will happen? The capacitor have a initially is 10 volt before T2 minus. At T2 minus the capacitor voltage is 10 volt, and when the input voltage is 0 at T2 plus, what is happening? That capacitor have a 10 volt with respect of ground, so that D1 is reverse bias. Why? Because if you talk about D1 and D2, so this is 0 volt, this is 5 volt, this is 10 volt, this is 10 volt. At T2 plus, if you talk about D1, then P1 side you have a, for D1 it have a 0 volt and it have a 10 volt. That the D1 is reverse bias, perfectly reverse bias. VA minus VB is not greater than 0 volt. Similarly for D2, this is 10 volt, this is 5 volt. The 5 minus 10 is not greater than 0. So at T2 plus, just at T2 plus, the D1 and D2 both are reverse bias. Both will be act like an open circuit. If you talk about D1, D1 can be forward bias when this voltage is less than 0, because this node have a always 0. This node have a voltage is fixed, that is 0. So if this voltage is less than 0 only, then I can say that this D1 will be a forward bias. Let's talk about D2. If this node voltage is less than 5 volt, then D2 will be a forward bias. Till 5 volt it will be a reverse bias. If the Vout or VC voltage is not less than 5, that remain D2 is reverse bias. This condition is remain same whenever that VC or Vout is greater than 5 volt. Till Vout is greater than 5 volt, the D1 and D2 is remain reverse bias. D1 will remain bias whenever that till it is not less than 0. But if you talk about D2, D2 can be forward bias but should be VC is less than 5. So I am just writing if Vout or VC greater than 5 volt, D1 and D2 both remain in reverse bias. Okay. So once you going for an interview now, you just make that waveform in a one line. Okay, just looking the circuit. If you are good in network, you just make the waveform that the output in a one line. But they will explain. Okay, they will try to stuck your concept at this point. Okay, just make it the circuit at T2 plus. They will ask in a way ki just design the circuit at T2 plus, what is happening of the D1 and D2. So if you are not good in understanding of that this input or node voltage and D1 and D2, so it will be problem for you. Okay, they will not start from T1 minus to something. They will just focus of any point, that T1 plus or T2 plus or T2 minus or T1 minus, any point they can choose, and just want at least explain at this point what is happening. So at T2 plus, the capacitor does not allow sudden change. This is 10 volt. Why this is not changing here? Because the D1 path is reverse bias. So it is not connected directly to ground. If you are looking from D2, so D2 is not short circuit. It's not a forward bias. It is a reverse bias. So it will not discharge with this path. Capacitor will discharge only with the resistance path. And if this capacitor is discharging with this path, it will take time. And that what tau is what? That tau is equal to RC. So if you are looking this waveform, before T1, what is the voltage? That T1 is VC is 5 volt. So this is starting from 5 volt. It is starting from 5 volt. At T1 plus, it have a sudden change to 10 volt. It is maintained 10 volt. And just after T2 plus, the D1 and D2 will be reverse bias and the capacitor discharging with this tau time. So before T1, after T1 have a sudden change that gradually changing rapidly fasting from 5 volt to 10 volt. But after T2, it have a time constant. The capacitor is discharging with the time of tau is equal to RC there. If you have a resistor and capacitor, that's not meaning that always it will take time for charging and discharging. This diode will help you to change the capacitor voltage gradually from 5 volt to 10 volt, where the tau is nearly about 0. If you talk about T1 plus to T2 minus. But if you going for a T2 plus, at T2 plus, the D1 and D2 is remain reverse bias. For a D1 to form a forward bias, it will less than 0 because this node voltage is 0 always. If you make D2 will forward bias, this node voltage should be less than 5. Then only it will be a forward bias. So of course capacitor is discharging from 10 volt to 9, 9 to 8, 8 to 7, 7 to 6, 6 to 5. And once it is trying to less than 5 volt, this capacitor is discharging. It is trying to discharge, but it will not discharge less than 5. Once the capacitor voltage is trying to less than, it will be 10 at T2 plus, it will become 9, 8, 7, 6. Once it become a 5 there, once it is going for a 5 volt, this D2 will try to become a forward bias. It is just like this, that capacitor discharging with the time constant of RC from 10 volt to 5 volt. But once you are going for a less than 5, this supply, the 5 volt supply, make a D2 is forward bias and it will remain is 5 volt. So in this question you have a 2 supply. That the second supply, they fix that V out is never be below that 5 volt. Okay, you can use this circuit once you require of that, okay, your capacitor voltage, your V out or VC or anything, your node voltage is not moving less than 5 or anything. You can put it 2, you can put it 3, any voltage. So it is starting from the 5 volt. It is never be less than 5 volt, never be less than 5 volt in this question. Or you can take it X. X should be positive. So if X is greater than positive, it will start from the X voltage. At T1 plus, it have a gradually to 10 volt. And after it T2 plus, that the voltage is decreasing, the capacitor voltage will decrease with the path of RC, that is exponential path, that after T2 plus it is exponential decreasing, but it can't decrease to 0 volt there. It can be decreased only to X volt if this is X here. If this is 5, so this is 5 volt. If it is 3, so it is 3 volt. If it is 2, so it is 2 volt. It depends on you. So you can design your own circuit as per the requirement, as per your waveform requirement. You can think in a way, okay, whenever you have a positive edge, so capacitor will take a very fast amount of the voltage and will be reached to maximum voltage in a very small duration. But once that supply, the input supply is that remove from that, so capacitor will not discharge fast as like charge. So capacitor will discharge with the path of resistance, and this diode will limit it. Okay, this will not discharge with the capacitor directly to ground, and this diode will limit it, and there have only path of capacitor discharging is R. So capacitor is discharging with the path of resistance, and it is discharging in a way, okay, it is discharging, but it have a limit. Once it will try to discharge below than 5 volt, this D2 will be forward bias and it will become a 5 volt. Okay, so this is your output there. Okay, and this discharging, it depends on how large or how small your RC. The waveform may be like this, the waveform may be like this. It depends on you. Let this is tau 1 and this is tau 2. So of course tau 1 is greater than tau 2. If your time constant is high, so capacitor will take large time for discharging. If RC is small, so capacitor will discharge fastly towards that, and it will not discharge, it never be discharged to 0. It can discharge till 5 volt or X volt as per your circuit design, as per your designing. Okay, you can design this. If you are understand this way, you can design your charge pump. Okay, just read about the charge pump and you will use these type of concept only. And charge pump is very important in a memory circuit. Once you go for the memory circuit, you will find the charge pump. Okay, you require some boost. Okay, and this is just like a boost for that. It will never be less than 5 volt. The output is never be less than 5 volt. Okay, so this is one of that a good question. Okay, and the interviewer never talk about the whole output. It will only focus for any region. Let's start with after T2 plus, after T1 plus, before T1. Okay, just interested on that sudden change. What will be the output response? How that output will be effect? How that capacitor will be effect? And if anyone interested to read that or write the equation after T2, you can write it. That capacitor voltage from final to final, that what will be the equation? If you want, you can write it. And the equation after T2 plus, VC or V out both are same. VC of T or V out of T both are same, because that V out with respect of ground is VC, capacitor voltage. What will be the finally it will be 5. Initially it was 10, 5 e की power minus T minus T2 upon tau there. So this is 5 plus 5 e की power minus T minus T2 upon tau. Yes or no? Okay. So it is decreasing, but it never be decreased to less than 5 volt. It is always be a 5 volt. Okay, so after some time it is decreasing from 10 to 9, 8, 7, 6, 5. But once it is trying to discharge less than 5, it will never be a less than 5. That diode D2 will be conduct and it will be a forward bias, and the output will be a capacitor voltage become a 5 volt. Please solve one of that question. If you solve this type of question now, so there is no any requirement to solve all RC question with a diode. You solve just one question and use all these concepts in this question, And if you solve this type of question, you can solve anything with the respect of diode or RC. Okay, let's go for that another part, that is charge conservation. That is very, very important point. Okay, I am starting with RC for charging or discharging for the positive S trigger or negative S trigger, and then we are moving for diode. Now we are going for a charge conservation. Okay, what is charge conservation? And we will simulate these diode based question on LT Spice on Sunday. Sunday we will simulate this question also, charge conservation based question also, and that will be what, that is diode based question also. Okay, so today and Saturday we will solve that charge conservation based question. That is very important topic, and this is regularly in use in your analog circuit design. Okay, so let's start with the charge conservation. So as the basic definition of charge conservation, the total charge in a closed system always remains same, just like always remain constant. In a closed circuit, that total charge is remain constant, and the definition is saying that the Q initial is equal to Q final, just like that you are thinking that the entering current is equal to leaving current at the node. Just like this, the total charge of initially will be remain same at for the final. Okay, so Q initial is equal to Q final. So let's try to understand what is the meaning of Q initial is equal to Q final. So I am saying that, okay, you have a capacitor and you have another capacitor, and this capacitor, that is C1, this capacitor value is C2, this capacitor have a voltage is V1, this capacitor have a voltage V2, and it is not connected before T1. Before T1 it is open, after T1 have a switch will close. So before T1, if I am talking about before T1, this is a closed circuit and you have a two capacitor. They are just like a floating with the initial voltage of V1 and V2, with the value of capacitor is C2, that is C1 and C2 and V1 and V2, and this is the initial phase before the switch is closed. So I can say that the Q initial before the T1, the Q initial is equal to what? That is Q is equal to CV. That Q is equal to CV. So what is the capacitor of that? That is C1. What is the voltage? That is V1. And both have a same direction of that positive negative. So that's why I am writing C1 V1 plus C2 V2. If the direction is changing, that I am writing C1 V1 minus C2 V2. It depends on the sign direction of the capacitor also. So please be important to define that sign. Okay, if you are not defining the sign and if you are not confident with the sign, so you will face the problem. Okay, so whenever you are solving any question like resistor, capacitor, anything, just focus on every time you have that voltage direction. Okay, the positive, negative. So I am just thinking in a way, okay, that Q initial is equal to C1 V1 plus C2 V2. And what is happening at T1 plus? So at T1 plus, that C1 is present here and C2 is present here with the diode, and now this capacitor is connected after T1 plus. The switch is closed, and once the switch is closed, so I can say that this is behave like a parallel now. This is one of the node, this is second of the node, and if you have a two or more than two element are connected with a pair of node, that is called parallel circuit, and in a parallel circuit the voltage is same. So what is happening here? This voltage become a V. I am just saying that the voltage V, that is voltage will be same for C1 and C2. Or you can think in a way, okay, this capacitor have a some voltage, that some charge with that Q is equal to C1 V1, and this capacitor have a charge with that Q is equal to C2 into V2. Once they are connected, just like this, you have a two bucket. In a two bucket, one bucket have a higher charge, means that the water level is higher, and the second bucket have a lesser level of that water level is less than that previous one, and they are individually put in a ground. And once after T1, if you connect one rod in between, that the one pipe you connected, so what is connecting, whenever you will find that less level and whenever you finding the higher level, that current or flow of charge is flowing from higher level to low level. So that always current is flowing from higher potential to lower potential, that higher charge to lower charge. So the charge is flowing from higher potential to lower potential or higher level to lower level to make it that level is remain same, to maintain that. So if you want, you just think in a way you have a two bucket, and two bucket have a some voltage and the charge and the capacitor, and similarly it have a charge here. The Q initial of both is C1 V1 plus C2 V2. Once they connect it, they will try to maintain a same level. If they want make a same level, the level is represent that voltage, that is V, and what will be the Q final here? That Q final will be become C1 into V plus C2 into V. Of course, they both have a same sign. That's why I am writing positive and positive. Okay, don't think in a way always I am writing C1V plus C2V. It's not always plus. It may be negative. It depends on that what is that. But always think in a way the charge transportation is happening in between these two conducting plate. This conducting plate is connected with this conducting plate. The charge is transferring. So this conducting plate have a positive sign. This conducting plate have a positive sign. So that's why I am writing C1V1 plus C1V plus C2V. And if you make it a charge conservation, that Q initial is equal to Q final, the total charge is remains same in a closed circuit. So you can use this Q initial is equal to Q final, and this will be what, that Q initial is equal to, sorry, Q initial, it is not Q final. Q initial is equal to Q final, and you just write it that C1 V1 plus C2 V2 is equal to C1 V plus C2 V. And what is V? You can write as C1 V1 plus C2 V2 plus C1 plus C2. This is the level of that bucket. This is the level of, this is the voltage that will be happening, so that both have a same voltage, both have a same charge. So Q initial is equal to Q final. So as it remains same for C1 V1 plus C2 V2 is equal to C1 plus C2 into V, and you find it that V is equal to C1 V1 plus C2 V2 upon C1 plus C2. If voltage is just once you connect that C1 V, that capacitor C1 and capacitor C2 after T1, that voltage gradually changing on both sides, and it will try to maintain that amount of voltage, so that charge is remains same for Q initial is equal to Q final. If you put it here and just solve that, the C1 V1 plus C2 is equal to C1 V1 plus C2 V2. Okay, so this is the charge conservation. I am just taking that, okay, this is one of that funda. Let's talk another circuit. You have a the input voltage here, and you have a two capacitor, and now this capacitor C1 and C2 are connected in series. In previous case they are in parallel, now they are in series. Okay, and I am saying that okay, this capacitor is present here. So what is happening? So let before T1 what is present here, let before T1 that C1 have a voltage is V1, let this is V1 and this is V2. Once that initially just like previous one, that capacitor C1 and C2 have an initial voltage is V1 and V2 and the input voltage is 0. So the input waveform is like this. I am just writing in a way कि okay, before T1 the input voltage remains same, it remains 0. After T1 it become a 10 volt. So if you are making that circuit, so before T1 what will happen here? Before T1 this capacitor and this capacitor are connected like this. If you are looking in a way, so this is connected in a short circuit path now because the input voltage is 0. So it is connected in a way, and this is C1 and this is C2. Yes, please. And when then they are 0, what will be the voltage here? Voltage is just like previous one, that C1 V1 plus C2 V2 upon C1 plus C2. Okay. So as per that ki okay, that V1 and V2 is not something like this, that V1 and V2 is just like a V, and that will be your voltage, that is C1 V1 plus C2 V2 upon C1 plus C2. So I am just saying that okay, this as per that before T1 this have a voltage is V and this have a voltage is V, both have a voltage is V, and once the input voltage is become 10, this capacitor is connected in such a way like this. And I don't know what is the voltage here. I don't know what is the voltage across C1 and C2, but I can say that the current is flowing in this direction. So this is 10 here and this is V out. So if you talk about the C1 voltage, the VC1 is what? So VC1 is equal to 10 minus V out. And if I am interested for C2 voltage, so VC2 is equal to 10 volts, sorry, V out, not 10, V out. And if this have a this path, so this is positive here and this is negative, this is positive here and this is negative. Yes, everyone. So the capacitor is charging in a way and the voltage across C1 is VC1 is 10 minus V out and VC2 have a V out minus 0. So both have a capacitor, that is VC1 and VC2. Now that capacitor have a direction of positive and negative. The left side is positive because the current is entering in such a way, and this is. So the charge conservation is happening in between two conducting plate, and this is the conducting plate where the charge will conserve. Yes, everyone. So the charge will conserve once the input voltage become a 10 volt. So this is the way. Okay. So Q initial is equal to Q final and I am saying that let the Q initial voltage is alpha. That initially it was alpha, that is C1 V1 plus C2 V2 upon C1 plus C2 is alpha voltage. That is just writing in a way. Okay, I am writing this is alpha. You can think that it is 0 or you can take that alpha. Okay, and what will be the finally it is what, that is C1 voltage is what, C1 voltage is negative because this have a conducting in a negative plate, because you are conserving the charge is the negative side. So this is minus of C1 into 10 minus V out. Just be focused. Whenever you are focusing on the charge conservation, be important that direction. This have a conductive plate, this is the negative side and this is positive side. If they are in series, so this is negative and this is positive. So the voltage you are charging and writing in a way that minus C1 into the voltage across C1, that is 10 minus V out. And what is the charge of C2? That is C2 into V out. Yes. So this is writing is minus 10 C1 plus C1 into V out plus C2 into V out. So V out will be what? V out will be alpha plus 10 C1 upon C1 plus C2. If alpha is 0, this is 10 C1 upon C1 plus C2. As you know that capacitor voltage, if you know that the capacitor does not have, this capacitor does not have any voltage initially. So what is the voltage of the C1? That is V in into C2 upon C1 plus C2. What is the voltage of the C2? V in into C1 upon C1 plus C2. We know that capacitor is 1 upon SC. That's why this is V in into Z1 upon Z1 plus Z2, and Z1 is what, 1 upon SC. So this is V in into C2 upon C1 plus C2. This is your voltage V1 and this is voltage V2. Okay, so similarly we prove it कि if alpha is 0, let that initial voltage is 0. So this the voltage V out of the C2 is 10 C1 upon C1 plus C2. And if you talk about what is the capacitor voltage C1, so this, the 10 minus of this will be your capacitor voltage. Okay. So this is the way you can, okay, this is the way you can solve the question. Okay. So today we have one very important question for you. Most of that time I've found that this type of question is asked. Okay, you have an input voltage, you have a resistance, you have a resistance here, you have a capacitor here, you have a capacitor here. Okay, this is R1, this is C1, this is R2, this is C2, and you will face this type of question when the input is just like the input. You can take any waveform, just I am making in a way okay, this is okay, and there you can try to different waveform. Okay, if you have a sudden change of input, then you find some quality of that question. If the input is changing with the time, so there is no problem, you just follow the basic funda that capacitor is 1 upon SC and you find it and you solve it. Okay. Whenever you have a sudden change of input, then you require, okay, what is that capacitor is happening, what will be that. Okay, if you have a sinusoidal input, there is no meaning, you just use that LTI system, you make the transfer function of that system and just check it, what is the frequency of the input signal. At the frequency of the input signal, you will find the output is changing on two parts, one is magnitude and another is phase. Okay, So the sinusoidal input will be the output of sinusoidal, but the sinusoidal with the same frequency have a change of magnitude and phase. Okay, so if you have a sinusoidal input or you have a time changing input, there is no problem. Just solve with the basic network, just like 1 upon SC, R1, R2, C2, and just solve it. But whenever you have a sudden change of that type of question, you require a time-based question. Okay, what is happening before T1? What will happen after T1? What will that sudden change? How it will be affect your output? How much current is flowing? Okay, that is very important. That's why this type of question generally asked in an interview. Okay. Okay. So let's figure out what will happening here. Before T1, I am saying that before T1, the initial voltage of C1 and C2 is 0. If it is not given, so I am just always thinking that capacitor voltage C1 and C2 is 0 before T1. Okay. So that before T1, what is happened? So at T1 minus, the input voltage is 0. If the input voltage is 0, the circuit is like this. So this is connected in a way. This is resistance, this is resistance, this is capacitor, and this is capacitor. And in a DC state, or I can say that this is a DC state, this is a DC state, it is a constant voltage, that I is equal to C dV by dt, that is current is 0. That's why I am saying that this, I am not talking about resistance, because I is equal to V is equal to I is equal to V by R, so there is no problem. Okay, so you just find it I and voltage and you can determine what will be the current. But in a capacitor, whenever you have a capacitor and you talk about the stable state or steady state or DC state or constant state, that voltage in terms of that the current is always be 0. That's why I am saying that the capacitor is act like, not is always, it is act like a open circuit, because nearly current is 0. And you have a resistance R1 and R2, and this is C1 and C2, and this is V out. There is no any external supply, and we say that the capacitor does not have a initial voltage. If there is have some initial voltage, so of course you have a R1, R2 have a voltage, because they are in parallel, and all have a same voltage because all are in parallel. If you are looking in a way, so this is ground there, this is 0. If you are looking this one, V out minus 0, V out minus 0, V out minus 0, V out minus 0, because all C1, R1, C2, R2 all are in parallel. The voltage will be same if you have a voltage here. So initially that I am just assuming that the initial voltage is 0 of that capacitor. So C1 or C2 does not have any initial voltage. So the circuit will be like this. The circuit is it is looking like this way. So I can say that, okay, if this the condition that capacitor VC1 is equal to 0 is equal to VC2, because there is no initial voltage or there is no any external voltage present here. What is happening at T1 plus? At T1 plus, the input become a 10 volt. Okay, when the input become a 10 volt, okay, what is happening that this is the circuit that have a sudden change of 10 volt. You have a resistance, you have a resistance, you have a capacitor here, and where that capacitor have a initial voltage is 0, because capacitor, as you know, that capacitor does not allow sudden change of voltage, so it will try to remain same. It will try to remain same because capacitor does not allow sudden change. But if you are looking this circuit and you are thinking that cap does not allow sudden change of voltage, across it, that means that at T1 plus the circuit will be like this. This is T1, this is resistance, this is resistance. That capacitor is act like short because the voltage of the capacitor is 0. So this is like this. And if you are looking this circuit, you can think that what will be the current. I am not saying that mathematically you can say that this is infinite amount of current is passing through C1 and C2, but physically the current is very large. That current through C1 and C2 is very large. So the capacitor C1 and C2 voltage will be gradually changes from 0 volt to some volt. And what will be the voltage? As per the previous question, what will be the voltage of C2? It will be 10 into C1 upon C1 plus C2. What will be the C1 voltage? That is 10 into C2 upon C1 plus C2. Like this, in a previous we solved that question. Okay, whenever you have a two capacitor are in series, so it will be 10 into opposite, that is 10 into C2 upon C1 plus C2, and this is 10 into C1 upon C1 plus C2. It depends on where are you trying to determine it. So by the looking of the circuit, if you are assuming that capacitor does not allow sudden change, the circuit will be like this. And if the circuit is like this, the capacitor through the current is passing, and the C1 and C2 have a very large amount of current, and if it have a very large amount of current, so C1 voltage and C2 voltage gradually changes from 0 volt to some volt, and the voltage is across C2 is 10 C1 upon C1 plus C2, and at C1 is 10 C2 upon C1 plus C2. Okay, so what will happen? So at T1 plus, the current is very large through C1 and C2, this will be 10 and this will be V out. You can use a basic definition that there is a charge conservation, and this is charge conservation between the two conducting plates. The charge is always conserved in between two conducting plates, and if you are assuming the current in this direction, this is plus and this is minus, this is plus and this is minus, this is conserving in between this path. The Q initial is equal to Q final, and initially you are saying that the voltage across C1 and C2 is 0, so that is 0, and the finally it is what? That is minus, that this is negative here, so this is minus C1, and what is the voltage? That is 10, and this is V out, so this is 10 minus V out, plus what is that voltage? That C2, and V out minus 0, that is C2 into V out. You can align in a one line, that is what is V out? V out is 10 C1 upon C1 plus C2. So at T1 plus, VC2 will be 10 C1 upon C1 plus C2, and VC1 is, you can write it 10 minus V out, or you can directly write it 10 C2 upon C1 plus C2. This is the way. So at T1 plus, that capacitor voltage is changing rapidly because that current is very large through R1 and R2. In between the path, there is no any resistance. That capacitor will charge rapidly with the large amount of current, and the voltage across C1 and C2 will be the different, that is VC2 is 10 C1 upon C1 plus C2, and C1 voltage is 10 C1 and C1 voltage is 10 C2 upon C1 plus C2. Okay. So this is happening at T1 plus. So please solve it after that. What is happening at T2 minus? When that T2 minus, the input voltage is 10, but that capacitor act like an open circuit. So the current is 0 through C1 and C2. Because at T2 minus, the input voltage remains same. So in a DC state, the current through C1 and C2 is 0. So the voltage across R2 and R1, the current flowing through the R1 and R2, that will decide the voltage. The voltage V out will be 10 R2 upon R1 plus R2. Please solve that question. Okay, I don't have too much time to solve it. Just please solve that question, and that is very important question. Okay, so please solve it. If the time is permit, we will solve in our next class. Okay. So I think you are trying to a RC circuit, because RC is, of course, RC requires some basic information of current and voltage, and you should have some idea that the current is large and current is small, that tau is 0, tau is not 0, that capacitor is changing or not changing. You must have a basic idea of that. And once you go for the diode or charge conservation or switches, it will become a more complex and complex and complex. Okay, so I am not going for very complex question. I am just giving a very small dose, so that you must make your idea, so that you can explain your output in a intuitive way. Okay, what is happening? But firstly, if you go for the analogy, you must have a understanding of what is happening inside the picture. If you understand the inside the picture, then only you can solve in a 1 minute or 2 minute. But if you don't know about this, if you don't know about the inside that part, so it is just like for you just remember that output and just you make it, and anyone just open that circuit, you will stuck. Okay, so please solve this question and just change it. Just change the position of R1, R2, C1, C2, and you can make your own circuit. You just make that you have one DC voltage here. Just design that question. It's up to you. Okay, so please design as question as you want. You can change it by the help of, you can put it one DC voltage here, you can put it one DC voltage here, you can put the diode here. It depends on you. Okay, so please solve that question. Tomorrow on a Saturday we will start a switch based question. That is also very important. When we start the time limit, okay, what is happening after this switch, after this switch, after this switch. Okay, and then we will go for LT spice and we will cover that RC. Okay, and then we will start MOSFET. So for now, thank you so much everyone, and please be solved at these question, this type of question. Thank you so much dear.